Lesson 10 Project Help video. So the farmer is almost done organizing the vines hanging in the barn. He has relabeled most of them, however there are two vines he can't quite seem to untangle. The first vine has a label of x to the fourth, and the second vine has a label of x to the third. He makes a drawing of the barn and tries to plot the two vines using a beam in the center of the building as the y-axis and the ground as the x-axis. He measures each foot as 1 unit. Frank notes that the vine labeled x to the fourth plunges into the ground at a distance of 2 feet to the west of the beam, resurfaces 1 foot to the west of the beam, then plunges below the ground again at a distance of 0 feet from the beam, and resurfaces 2 feet to the east of the beam. What could this graph of the vine look like? Well, let's draw ourselves a graph here. So we have, if you don't remember your cardinal directions, we have never eat sour watermelon is the way that I learned it. You may have learned it a different way. So we have never eat sour watermelon is the way I learned it. So we're going to start. We got 2 feet to the west of the center beam. So here's our center beam. 2 feet to the west. West is to the left. So that means we got 2 feet to the west of the center beam. It resurfaces right there because remember our x-axis is our ground. So that's where it plunges into the ground. Then it resurfaces a foot to the west of the beam. So 1 foot to the west, we're here. So it's coming down, plunging into the ground. Now it's coming back out of the ground. Then it plunges below the ground again at 0 feet. So now it's plunging back down here at 0. And then it resurfaces 2 to the east. East is to the right. So we got 2 to the east is where it's resurfacing again. So we're going to have a graph that looks something like that. So here's a better drawing of what the graph looks like. So it's something like that. So as you can see, we have it crosses here at -2, -1, 0, and 2, just like how we kind of drew it. Okay. Refer to the previous question based on the answer you chose in the last question. Approximately how tall is the highest loop of the vine represented by the label x to the fourth? And is it located to the east or the west of the central beam? So if we look at our graph here, we want to know the highest beam. So it doesn't matter how far up these go, because remember that just on our graph means that they go up forever. We want to know the highest loop, so we want to look. So it comes down, that's not our highest. That's our highest, and that's a low again. So we want to know this part here because that's our highest loop. How far is it? So if we look here, it's only 1 unit up. So it's 1 foot. And is it to the east or the west of the center beam? Well, it's to the west because it's to the left of that center beam. So it's 1 foot to the west is where our highest loop is located. Okay. Frank notes that the vine labeled x cubed surfaces from the ground and goes up to the rafter 6 feet to the west of the center beam, plunges to the ground 3 feet to the west of the beam, and resurfaces 2 feet to the west of the beam. What does the graph of the vine look like? Well, let's go ahead and draw it again like we did last time. So we have it first, it surfaces from the ground, so we're coming from the down up 6 feet to the west. So I'm going to draw 6 to the west, so 6 to the left. So it's going to come up and cross through that 6 to the west. Then it plunges into the ground 3 feet to the west, so I'm still to the west, so I'm still to the left. 1, 2, 3, so right here. It's going to come and it's going to plunge down into the ground, and then it's going to resurface again 2 feet to the west. So it's still to the left of the beam. 1, 2, and it's going to resurface again. So our vine graph should look something like that. So here's a little bit better drawing of it. So it comes up at 6, goes down at 3, comes back up at about 2. Okay. Refer to your previous question. Based on your answer to the previous question, how tall is the highest loop of the second vine? Is it located east or west of the central beam? So here is our drawing. We want our highest loop. So here's our highest loop. If we follow this over here, we're at 7 feet. So it's 7 feet tall, and then is it east or west, so to the right or to the left? Well, it's to the left again, so 7 feet to the west is where our highest loop is located. 7 feet tall, and it's to the west. Alright? If the farmer cuts the two vines where they cross each other, he can untangle them. If one vine's full equation is v of x equals x to the fourth plus x cubed minus 4x squared minus 4x, and the other vine's full equation is p of x equals x cubed plus 11x squared plus 35x plus 32, how many cuts will he need to make? Keep in mind that the barn is 30 feet tall and the farmer may need to dig in order to find where the vines cross. So I went ahead and I used a graphing system to help me graph the two graphs. So here is our two graphs of these full equations. So the first thing we want to look at is that we know the barn is only 30 feet tall. So that means that we have a maximum here of 30 feet. So I'm going to go ahead and draw a line there. And I don't care about anything that's up here above 30 feet because our barn is only 30 feet tall. So anything above that doesn't matter. So if I want to cut these vines in order to untangle them, I need to know how many times do they cross each other. So if I follow my green line here, I'm going to circle every time they cross. So here the green and red cross. If I keep following my green line, there's nowhere else where they cross. So it looks like they only cross once. So that means that the farmer Frank, needs to just make one cut and he can untangle the two vines from each other. So I hope that this helps with your Project 10 lesson. If you have any questions, feel free to contact me.